Hey everybody, welcome. So the whole topic we're doing now is about electrostatics, which is all about charge interactions. We're talking about protons and electrons and how they interact with one another. Positive and negative charges, repelling, attracting, whatever they're going to do. We're going to play around with that a little bit. So all these demos should hopefully get you to understand that. The first one we're going to do today involves this. This is called a vinylite strip. When I apply friction to this vinylite strip, okay, it is going to steal electrons away from the material. So it's going to gain a negative charge. Now it is a insulator, it's plastic, so that charge will stay there and actually stay in the location where I apply the friction to. So if I charge the far end, then where I'm grabbing is going to stay neutral, especially because I'm grounding it, touching it at the same time. We're going to also use this empty soda can here as the other part of the demo. It is aluminum, which is a good conductor. So we're going to see what happens when we bring those two things together. So now I'm going to give that charge, that vinylite strip, give it plenty of friction. Okay. And then when I bring it close to that soda can, you can see that I can actually cause the soda can to move in the direction of the vinylite strip. Okay, so I can actually steer it without touching it. Okay, so hopefully you can see that there's a gap between the vinylite strip and the can. I am definitely not touching it, but I'm causing it to move in the direction of the vinylite strip. So here's what's going on in that demonstration. So as I bring this negatively charged object close to my can, okay, my can's a metal, okay, it has its valence electrons and its sea of electrons that can move pretty freely through it, so it's a good conductor, okay. So as I bring a negative charge close to it, those electrons on the side that are closest to the strip are actually going to go towards the opposite side of the can. They're going to start moving away from this edge that's closest to the strip because, well, they don't want to be close to that negative charge. So with that negative charge moving to the other side, that leaves the side closest to the vinylite strip with a net positive charge. It's lost some of its electrons and has more protons than electrons. The can itself is still neutral. It still has the same number of electrons and protons. I didn't add anything to it. I didn't take anything away. I didn't conduct anything onto it or away from it. Okay, but the can has shifted its charge location. So it is more negative on the side away from the vinylite strip and more positive on the side closest to the vinylite strip. Because of that, well, if I have a neat positively charged side here and a negatively charged strip, well, what are they going to do? Well, they're going to attract. So the can's going to start to move towards it. And as it rolls, that negative side that maybe used to be here is going to continue to be on this side of the can, but it's going to change location in terms of reference to the can itself, right? So the can's rolling, electrons are going to continuously start to move in this direction away to that side, leaving this side always positive, this side always negative. That's kind of the first demonstration of the concept of polarization. This thing is still neutral. I didn't add or take away electrons from it, but I did create a positive side and a negative side by putting that negative charge from the vinylite strip close to it.